Now we'll continue with another lecture on iodoform. Right? Before this lecture, we were doing chloroform. So iodoform, it's similar. In chemical properties, iodoform is similar to chloroform, with one difference, that iodoform is less stable compared to chloroform. Right? Chloroform is more stable. So the chloroform is, the formula is CHI3. That means this is also a polyhalogen compound because it has more than one halogen compound, and this is a triiodo derivative of methane. Right? Methane is CH4. Right? If you replace 3 hydrogen atoms with iodine atoms, what you will get is triiodoform. Right? Or iodoform. So we call it iodoform. Right? Now let's look into its preparation. The reactions are similar to what we have done in chloroform. Right? So preparation would be through same reactions. We call these reactions as haloform reactions. Right? Since we are preparing iodoform, this would be an iodoform reaction. Right? In this, iodoform would be prepared from ethanol, right, by treating it with sodium hypoiodide. Right? And how to form sodium hypoiodide? Sodium hypoiodide is formed, actually the products that are there in this haloform reaction is your methanol, iodine and sodium hydroxide. Right? Sodium hydroxide with iodine will form sodium hypoiodide. Right? Now this sodium hypoiodide will oxidize, right? Oxidize and will chlorinate. Sorry, not chlorinate, since this is iodine, so it will undergo iodination reaction. Right? So first it will oxidize your methanol to form acetaldehyde. Right? Then in the third step, it will undergo iodination. Right? Sodium hypoiodide will iodinate this acetaldehyde, right, where these 3 hydrogen atoms of acetaldehyde would be replaced by iodine atoms to form triiodoacetaldehyde. Now this triiodoacetaldehyde will undergo hydrolysis by sodium hydroxide to form iodoform. Right? And iodoform is a yellow crystalline solid, right, whose melting point is 302 degrees Celsius. Right? Remember the color. Right? And now let's look into the second reaction. Right? Remember the reactions oxidation, iodination, hydrolysis that we have done in the previous lecture on chloroform. Now you can prepare iodoform from acetone as well. Right? So you will treat acetone with iodine and sodium hydroxide under little heat. It will form iodoform. Here also sodium hydroxide will react with iodine to form sodium hypoiodide, which will act as which will iodinate your acetone, right, at one of the methyl groups to form triiodoacetone. Right? Now this triiodoacetone will undergo hydrolysis with sodium hydroxide to form iodoform. Right? Here also the same reactions. You have first reaction where sodium hypoiodide is formed, which will iodinate one of the methyl groups of acetone, right, to form this compound, and then this triiodoacetone will undergo hydrolysis with sodium hydroxide to form your chloroform. Right? And the smell of iodine is unpleasant. It has an unpleasant smell. Right? And this compound iodoform is insoluble in water but soluble in ethanol. Right? Soluble in ethanol, insoluble in water. Remember. And it is, since I said in the beginning that iodoform is less stable compared to chloroform, so iodoform will dissociate to give you iodine gas. Right? Vapors of iodine. These vapors of iodine we know are antiseptic in nature. Right? These are antiseptic in nature, so that is why it is used to heal wounds. Right? It is used for dressing wounds. This is one of the most important use of iodoform. Right? Because of its ability to form iodine gas. Right? Now let's look into its chemical reactions. We have already discussed it is less stable compared to chloroform, and it releases iodine gas, right, which has antiseptic properties, so it is used to dress wounds. Now its reduction, it will be reduced in the presence of phosphorus and hydrochloric acid to form diiodomethane, right. This is similar reaction one we have done in with chloroform. Now its hydrolysis, it will undergo hydrolysis with alcoholic potassium hydroxide to form formic acid, right, which will react with potassium hydroxide to form potassium formate, right. Now just look at this compound again. Here all these three iodine would be replaced by OH, right. We know now it has, this compound has three OH groups attached to the same carbon atom, right. So this is an unstable compound, right. So it will lose one water molecule to form carboxylic acid, right. Then the other most important reaction is carbylamine reaction, where it will react with aliphatic and aromatic amines to form a unpleasant smelling compound known as isocyanide, phenyl isocyanide, right. This reaction is used to test aliphatic and aromatic amines, right, because aliphatic and aromatic amines with your iodoform and chloroform will form isocyanides, carbylamines, right. These are carbylamine, that is why we call these reactions as carbylamine reaction. So it will form an isocyanide which has an unpleasant odor, right. Now coming on to its reaction with silver, it will react with silver to form acetylene, right. This is same as chloroform reaction. With silver nitrite, it will form a yellow precipitate of silver iodide, whereas chloroform has no action on silver nitrate, no precipitate formation, right. I hope this is clear. Just remember this reaction, silver nitrate, with silver nitrate it will form yellow precipitate of silver iodide, whereas there is no action on chloroform, right. And there is one more use, it is used in the manufacture of some medicines, right, in pharmaceuticals. So I hope all this is clear. Thanks.